Hey everyone, we are going to be starting chapter 5 today. We are going to start something called systems of equations. So, today we're going to learn how to go through those graphically, and then we'll start learning how to do different methods of solving as we go along here in this chapter. So, first off, we have to talk about what a system is, okay? A system of linear equations. It says two or more linear equations with the same variables to be solved together. Okay, so two different equations with the same variables. Almost always you're going to see x and y, and you're going to solve them. Okay, find something that solves both equations at once. Okay, so a solution, that's what we're looking for. So a solution of the system of equations, it's going to be an ordered pair. Okay, some x, y pair. That makes both of these equations true when you substitute it in. Okay, there's plenty of points that it's going to make one line true and plenty of points that makes the other line true. There's only usually one point that makes both of them true, and there's exceptions to that. We'll talk about that at the very end. Right, so essentially, I'm giving you two equations. Okay, give you one equation, then another equation, and you have to tell me the point where those two equations intersect. Okay, the XY point where they intersect. That's what I'm looking for no matter what method you're using. Today we're using graphing. We're going to use these other little algebraic methods to solve it out. No matter what, that's what I am after, that XY point that those lines intersect. There's this whole section here about checking if the ordered pair is a solution. Honestly, since we want to cover this in one day, I'm going to skip that. We are just going to do these different problems. The most important thing that you know is, okay, I can take these two different equations, I can graph them, and I can figure out what that point where they intersect is. So these are easy enough. They are already in slope-intercept form, which is great. Sometimes you're going to have to rearrange them a little bit. So let's start with the first one. I'm going to do this first one here in pink. Okay, so y is equal to negative 2x plus 5. So I know my starting point right here is 5. Okay, that's my y-intercept. And my slope is negative 2. So I'm going to go down 1, 2, and over 1. I'm going to try and make my life a little bit easier. I'm going to have a whole bunch of points, so when I plug in this line, it looks good even on the laptop. So down 1, 2, and over 1. Down 2 over 1. Down 2 and over 1. Okay, and I can kind of clean up some of these other... Okay, obviously these are just the dots from when I'm counting. They're not the dots on the line. Okay, so I'm going to go ahead and make my line here. So let's try and make that as accurate as I can. That's one of the bigger things to think about when we are graphing these systems, is you have to be super accurate as you can possibly be, because you're finding where do these two lines intersect. If you're being super sloppy with your lines, you might come up with a totally different point than what you're supposed to. Oh, I meant to write that, not use the... There we go. So always have the little line, or the little arrows at the end of your line, and then let's use blue. Let's come up with my second line here. This y is equal to 4x minus 1. Okay, I know my y-intercept is negative 1. And then my slope right here, my m, is positive 4. So 4 over 1. I know I'm going up 4 and over 1. Okay, so up 1, 2, 3, 4, and over 1. Awesome. It looks like I have 2 points right here at the same, or 1 point right here that are in both of my lines. Okay, so I kind of already know this is my line, or that's my point. Okay, so I can go ahead. I'm going to try and connect these two. I'm going to do that actually in just a black line over here. Then I have my arrows. Okay, so I know right here, this point is where they intersect. So that's at, my x here is 1, and then my y is, okay, 1, 2, 3. So 1, 3 is that point where my two lines are intersecting. Okay, you have two equations, you graph them both, you see where they intersect. All right. For the most part, I'm really not trying to give you any, you're not trying to look and see, oh, is that at 2.5? Really, we're going to give you points that are exact. So be very careful with how you're graphing. If you graph kind of sloppy, you might end up off a little bit. And that's why it's important to use graph paper too. If you try and just kind of half, do some little sloppy one in notebook paper, it's going to be pretty much impossible to tell where exactly that intersection is. All right, so let's keep on going. All right, so now we've got a couple equations that are not in just slope-intercept form, they're in standard form, so we know we have to do a little bit of algebra, move some stuff around, and then we can get our equations here in slope-intercept form. So we know that's our first step. We want to put it in that y equals mx plus b format. All right, so let's start with this x plus y equals 6. I know I want to get just y on its own, so I'm going to subtract x, and I do that from both sides. So I get y is equal to negative x plus 6. Okay, so I know that negative x is really negative 1 there for my m value. Okay, so I know that this one has a slope of negative 1 and a y-intercept of 6. So let me go ahead and graph that one first, and I'll deal with my second equation. Okay, I know my starting value here is positive 6. And then my slope, okay, my m I know was negative 1. If I want, I can think of that as negative 1 over 1. So I'm going down 1 and over 1. Okay, so let me come up. I like to come up with a bunch of points here. So down 1 over 1. I'm going to just do a couple of these and draw my line. Okay, draw my little arrows. It might happen sometimes where you draw a line and you realize, oops, I didn't quite go far enough, it doesn't intersect. Okay, you can always just add on to it if you realize, oh, I didn't make my lines long enough and they didn't quite intersect. Okay, but let's look and see what we have here for our second equation. This 2x minus y is equal to 9. All right, first off, let's get rid of that 2x. Let's move that to the other side. All right, so now I have negative y is equal to negative 2x plus 9. Okay, so just like any other coefficient, let's think of this like negative 1 here in front of the y. All right, so just like if it was a 3 in front of the y or a 4 or negative 2, I need to get rid of that. I need to have just regular y here. So I need to go ahead and divide both sides of this equation by negative 1. Okay, so that cancels out. I just left with y. And then I divided both terms here by negative 1. So really that just means I changed the sign. So negative 2x becomes positive 2x, and positive 9 becomes negative 9. Okay, so now here is my equation in slope-intercept form. So, okay, my y-intercept is negative 9, and my slope here is positive 2, so positive 2 over 1. I'm going up 2 and over 1. So up 2 over 1, up 2 and over 1. I'm going to keep going. And it looks like I almost went far enough with the other line. It's pretty obvious this is the point where they intersect. Okay, up 2 and over 1. I'm going to draw my line. Okay, so starting here. That one's not quite right. It's a little bit difficult on the computer. Hopefully it's a little bit easier if you have a ruler or something like that at home. There we go. Okay, and then I can kind of extend this line. I guess I should have made the other one a bit longer. All right, so we can see right here, this is our point of intersection. So we have, okay, we need the actual coordinate. So we're at x value 1, 2, 3, 4, 5, and y value 1. So 5, 1 is where these two lines end up intersecting. Okay, so that's basically all there is to it for just regular cases. Sometimes we are going to have these different cases where you have special exceptions. So we'll talk about that. Actually, if you want, you can go ahead, pause your video for a second. If you have these notes, you can try and work along with me. If you have these just maybe on graph paper, see if you can pause your video and come up with the same answers I do. I'm not going to work these all out like I normally do. See if you come up with the same thing I do. All right, so hopefully you came up with the same answers that I did. You can look at those here if you want. So we also could have these different kind of special cases when we graph certain lines. So usually when you get two different lines, you're going to end up with two lines that intersect in one point. That's the most common thing that happens. Sometimes we have something else. So let's look here at this first example. Okay, we have y is equal to 2x plus 2. Okay, so 2 here is our, 2 is our starting point. It's our y-intercept. And we have a slope of positive 2. So we're going up 2 over 1, up 2 over 1. All right, so I'm going to draw my little line here. With my arrows. And then same thing for now my next equation. I have 2x minus 3, so I have negative 3 here as my y-intercept. And then, again, positive 2 as my slope. So I'm going to go up 1, 2 over 1, up 2 over 1. And I can continue on and on. I'm going to draw my line. And we see that these lines aren't intersecting. Okay, I can see what I can do. Okay, well, what if I extend this line over here? I can make this line a little bit longer. I'm trying to make sure I keep this slope the same. There we go. And then, okay, well, I can make this line longer as well. Oh, I didn't start in the right place. That would help. Alright, so something pretty close to this. Again, it's not 100% perfect because I am working here on my laptop. These lines are not going to intersect. Okay, I remember when we were talking about parallel lines, when we were talking about writing equations for lines, these lines here are parallel. They have the same slope. So no matter what, these lines are not going to intersect. Okay? So when lines don't intersect at all, we say that they have no solution. All right, well, we have notes for this at the next page. I'll do that after I do the next one. So these lines have no solution because there's no place where both of these lines have the same solution at once. They're never intersecting with each other. Okay, so it's not possible for both of these lines to share any solutions. All right, and now let's see what happens when we have this line over here. And I actually don't know why I have all these random marks. over here. All right, so I have y is equal to negative 3x minus 4. Let's just go ahead and graph that. I've got negative 4 as my starting point and negative 3 as my slope. So I know I'm going down 3, down 1, 2, 3, and over 1, down 1, 2, 3, and over 1. So I'm going to draw my line. I'm going to try and make this one a bit longer. All right, and I have now another equation, not in slope-intercept form, so let me do the math there. I've got 3x plus y is equal to negative 4. And I know I need to move that 3x to the other side, so I'm going to subtract 3x from both sides. And I get y is equal to negative 3x minus 4. All right, well that sounds awfully familiar because it's the exact same equation that I just graphed. Okay, I'm starting here at negative 4 and I'm going down 3 and over 1. It's literally the exact same line. So I can draw that again. Let me do it another color. Okay, it's literally the exact same line twice. So instead of there being no points or one point where they have the same solution, every single point along that line that goes on and on and on forever is a solution. So here we would say there's infinitely many solutions. All right, so we can see this here. It says the graph of the system is a pair of lines that intersect at one point. That means this system has one solution. Okay, just like we're used to seeing. Two lines, there's one place where they intersect. We could have the graph of the system as a single line. We could graph one line, and then we could graph our second line and realize it's the same line. Okay, this type has infinitely. Why did I try and spell infinitely with an N? That's why I'm a math teacher. Okay, infinitely many solutions. Okay, there's as many solutions as there are points on a line, and that's infinite because this line goes on and on forever in either direction. Or we could have the graphs be a pair of parallel lines, so there's nowhere that they intersect. Okay, they keep going on at the exact same angle forever, and they're never going to intersect, so that means they have no solutions. All right, so exactly one. Okay, you have one place where they intersect. It's intersecting along this entire line, and then there are absolutely no places where they intersect at all. Right? So that's basically all there is to it. I know there's a ton of information in this section. I would say graphing is maybe the most time-consuming method of solving these systems, and we're going to move on tomorrow to solving these out algebraically. You have, either if you picked up the packet or if you just look at the assignment for today, I have that posted for you. Make sure you can either print that off or you have graph paper, and I'll see you guys tomorrow.